Okay, hello and welcome everyone. So my name is Sergio Bacallado and I'm an admissions tutor at Magdalene College, and I'm also a mathematician teaching at the university. And welcome to our webinar today, which is on engineering, studying engineering in Cambridge, and how to write a strong application in engineering. So I'd like to start by introducing our panelists, starting with our student panelists. So our first panelist is Areeg.
Hi everyone, my name is Areeg Emarah. I'm starting my 4th year doing information computer engineering at Trinity College, and I'm Egyptian, but I'm an international student from Kenya.
Thank you. And we also have Odu.
Hi guys, I'm Odu. I am also an international student studying engineering at Sydney Sussex College, entering my 3rd year now, specializing in mechanical/aeronautical engineering.
Great, thank you. And then we have Ali.
Hi guys, I'm Ali. I'm a 3rd year engineering student at Queen's, and I'm specializing in mechanical/aeronautical in this year, so my 3rd year.
Great, thank you, Ali. And we have Alexander Olive from Target Oxbridge. Alexander, maybe if you can say hi. Okay, and Dr. Richard Roebuck, also a fellow at Magdalene.
Hi there. Yeah, I'm Richard Roebuck. I'm Director of Studies in Engineering here at Magdalene, and used to be the admissions tutor, and I also run the Dyson Centre in the engineering department. And if it's helpful at all to say, this is my 26th year at Magdalene.
Yeah. So Rich is an expert both in admissions and engineering, so you're in luck today. To start our session today, Rich will be giving a talk about studying engineering in Cambridge, careers in engineering, and also potentially something about applying to engineering. And then when he's done, we'll move into our Q&A, and you'll be able to submit questions. I just wanted to point out where to submit your questions. So if I can ask people to use the Q&A feature in Zoom, which is in the bar, the toolbar at the bottom of the screen, instead of the chat function, that will help us sort the questions a bit more easily. And you're welcome to start typing them during Richard's talk, or at the end. Okay, so I'll let Richard take over now.
Okay, so let me just share my screen with you so you can see the presentation that I've got here. So share screen, and hopefully this should work. So my plan for today is to talk through with you about studying engineering at Cambridge as an undergraduate, and then that'll be the main part of what I'm talking about. I'll also touch on opportunities for graduate engineers, and I'll mention a little bit about engineering research. And then, as Sergio says, we'll come back to the Q&A with the panel and you, the audience. So to start with studying at Cambridge then, so I guess the main question to start with is, what are you actually studying? What is engineering? And this is a relevant question because if you were coming to university to study physics or maths, it's probably something you've already studied a bit at A level, but engineering, you haven't. So in this sense then, maybe Albert Einstein is a good person to draw on here. I kind of feel like I trust what he says. So he suggests that scientists investigate that which already is, so they try and find out how things work, whereas engineers create things which have never been. In other words, they put together knowledge and skills to try and create something new, something that hasn't occurred before. And another way of looking at it is to say that engineering is the application of scientific knowledge and maths to solving real-world problems. So why study engineering? Well, hopefully you're sort of here because you actually enjoy doing things with maths and technology, being creative in the way that you maybe solve problems. And the key benefits to studying engineering are that you get a rigorous training that can be applied to a whole range of different careers. There's a huge range of engineering areas, and it helps you develop your sort of scientific creativity and team working skills. It also enables you to make a difference to the real world, and I think that is important in this day and age. And it also has excellent job prospects, which also feels quite important in this day and age. So at Cambridge, we're a unified department. We cover a whole range of different areas: aerothermal, bioengineering, civil, electrical information, manufacturing and mechanical engineering, though chemical engineering is its own department. In terms of why you might though want to come and do a course where we have an integrated first and second year, so in other words, you'll study a whole range of different bits of these different courses in first and second year before you finally specialize in third and fourth year. Well, if you actually speak to people, it turns out that around about a third of people end up studying a different form of engineering here to that which they thought they originally would. So we've got an interesting example here of a person who has gone on to be a very, very successful civil engineer, but when she first came to Cambridge, actually was pretty sure she didn't want to be a chemical engineer or a civil engineer. And again, this is the same issue we've already highlighted a bit. Because you're not studying any of these different types of engineering at A-level, it's very hard to actually know for sure what you want to do. So to have the first 2 years to actually try a whole range of these different things is quite important. If you actually boiled it down to sort of individual sort of areas, in second year, for example, there's about 16 different topics that you're actually covering and looking at, any of which you might want to specialize in your third and fourth year. So what are these specialisms? Well, the sort of research and the specialist areas kind of go hand in hand. So here we've got aerospace and aerothermal engineering, and that looks at things like how fluids flow, how wings work. We've got, for example, a picture here of one of our lecturers who also, it turns out, is an astronaut for the Canadian Space Agency, and she looks like she's enjoying herself quite a lot there in a weightless environment. We've also got a picture of a ski team testing in the wind tunnel over here at the side. Another area that you might be interested in or that you might want to look at is electrical and electronic engineering, and that kind of dovetails really nicely with information and computer engineering. And so here we've got some examples of things that have happened. We've got parts for a supercar that were sort of developed by our control experts. So they're to do with the steering system and the suspension system, and so they help control how it moves. There's also robotics involved in there, and the sort of the interesting interfaces between humans and robots as well. Equally though, in these kind of areas, there might be sort of techniques for helping to enhance surgery, solar panels for racing cars, and I don't know exactly what this person's doing over here, but I sort of hold quite sort of well with the theory that everyone likes a laser beam, and that looks like what's being used in there. Another area is civil and structural engineering, and that sort of dovetails nicely with environmental engineering. And so again, we've got some interesting examples here to do with examining earthquake damage, or to do with trying to get water supplies for people. We've also over here, this example is sort of a little hard to see, but what's actually happening there is that fiber optic cabling is being added to these reinforcing bars. And that's going in before then tens, thousands, hundreds maybe of tons of concrete are poured in on top of these reinforcing bars, burying them. But it then means that as the building or bridge deflects and moves, that you actually can pick up some signals through that fiber optic cabling. And so in a way, you can then monitor how the structure is behaving throughout the entire course of its life. Another area is mechanical engineering, and this also goes hand in hand with bioengineering. So in other words, the mechanics of what's happening within bones and surfaces and that kind of thing. So we've got here sort of, it's not very clear what's going on there, but it's an interesting looking pair of slides. One is to do with porous implants in the body to try and encourage bone to grow into the little holes. And the other one is using fluorescent bacteria over here, which is actually part of the soil stabilization experiment. Got here one of our students visiting Tata Steel. And then equally in the same area, we've also got superconductivity. That also happens in this area as well. And I'll come back a little more to mechanical engineering towards the end of the talk. So at Cambridge, we're the biggest department in the university. Engineering represents 11% of Cambridge University. It's got 175 teaching staff, 320 postdoctoral research staff who might also end up teaching you, 950 graduate students who might also end up helping teach you, and then undergraduates, there's about 1,200. And at the moment, about 24% of those are female, and of the order of 40% are from outside the UK. So there's about 50 nationalities represented there within our undergraduate population. In terms of what's unique about the Cambridge course, that slide's gone a little bit funny there. What you've got is a unique structure, gives you a grounding in all main engineering areas before you choose your specialism. So you get an unrivaled breadth of knowledge, but then when you specialize, you've got an unrivaled knowledge. And you put fiber optics into that building, well, there's information and communications engineering going on there. It's kind of maybe sort of electrical engineering and computing as well to process the results. So if you were leading that team, your main specialism might be civil engineering, but you'd also want little bits of these other forms of engineering in there as well. We're an internationally recognized centre of excellence, and we have many partnerships with industry. And Cambridge is still in what's called the Silicon Fen, if you compare that with the Silicon Valley in America. We've got comprehensive facilities, decent labs and libraries, and there's an unparalleled level of student support as well to look after you as you go through your degree. So, as you go through that degree, what does it look like? Well, we've said that it's an integrated course. So we start off with 2 years covering all those topics that we talked about. A few people head off into chemical engineering. So if chemical engineering is of any interest, you can get to it via engineering first year or natural sciences first year. Then in third year, you tend to specialize in either one or more of those areas we've talked about. You can do something that's called manufacturing engineering, which is part of our department, though a separate building. And the chemical engineers, just to sort of emphasize, they would stay with chemical engineering normally for their third and fourth year, but they can, after doing 1 year, choose to come back and do manufacturing engineering if they want. There are a couple of exchanges there. For the entire third year, you can either go to Paris or Singapore. So there's two quite different places in terms of temperature and experience. It's for a very small number of people, typically about 4 in total, but if that's something that interests you, it's definitely worth pursuing. And then at the end of it all, everyone graduates with a BA. That's standard in Cambridge. Your first 3-year degree is always a BA. And then for your fourth year, you get a Master of Engineering, irrespective of which of these options you've taken. In terms of the specialization, I feel that that's one of our very best points, in that for that third and fourth year, there are 120 different modules to choose from. So you end up doing 18 of those, 10 in your third year and 8 in your fourth year. But 120 different choices here, pretty much. It is a vast amount you can choose from. So one thing that you might like to do is, you can see this list of modules online. You might like to try and just sort of pick out which ones you might wish to do. And actually, it's normally a case of there's normally more that you want to do than you actually have the time available. As long as you take up to half your modules from one area, then you qualify in that area, or actually you could maybe try and qualify in 2 areas. So with a suitable selection of modules, you could qualify with a degree in mechanical engineering, but also bioengineering as well. Or if you want to keep everything broad, that's fine, that's not a problem. You would just qualify in engineering rather than any particular type of engineering. And what would a typical week look like for an undergrad? Well, in engineering, we try and keep all your department commitments mainly to the morning. So you can see here that you've got a mixture of lectures and laboratory sessions. Examples means you've got a lecture style session where they go through questions with you. And then in the afternoon, well, it's down to you what you do. You need to do some private study. Also, occasionally a department commitment is in the afternoon. You also have supervisions, or you might regard these as tutorials, where you'll get together with an expert to discuss the problems you're having. Or for some of the time, you'll actually do something that's outside of engineering. You might have some leisure time. So that's part of the interesting freedoms of being at university. You get to pick and choose and arrange your life as you want. You have to do enough work, but equally there is time to have some fun as well. And that's important. In terms of our library, well, it's well stocked. It's got over 30,000 books and over 300 different journals are kept. So that's sort of scientific magazines that come in. But it's not just about books anymore as a library. In this case, there are some silent spaces where you can work away from noise. There's also some collaborative spaces that we can see over here with those people busy discussing problems there. Or rather, I assume it's problems and not just trying to plan some kind of sporting event. But the point is you can use it for what you want to use it for. Students also have access to the main university library, and also every college has at least one library. I think Magdalene currently has 3 different ones, but there's only one of them which is keeping modern books. In terms of computing, you've got over 200 computers you can access that are dedicated to you for 14 hours of the day, 7 days a week. Although a lot of people choose to have their own computer, and then you can have the flexibility of being able to use that wherever you want. The beauty of the department machines is they have all the software installed that you need for specific exercises. And almost unique to us, we also have a specialist language unit. So you can combine with your study courses in Chinese, French, German, Japanese, Spanish, and they also arrange trips, cultural activities, and they've got a wide range of resources. So in other words, if there's a language you want to study that they don't specifically do, they do still have books, cassettes, and learning aids you can borrow. We also have what's called the Dyson Centre for Engineering Design. And this is a project space, a place that you can come to and try out some of the ideas you've seen in lectures, try them out practically and in reality. You can either do this yourself or with friends. You can work as part of a student team if you want. And we've got the Formula Student race car at the bottom here. We've equally got one of the art sculptures teams here who's produced a laser cut snowflake. And then over at the side, some examples of 3D printing, and then one of our technicians repairing a 3D printer, just to show that actually we do get a bit hands-on in that one as well. And some of the student teams actually do get involved with the technology. So we have a 3D printing society, and they also like to come in and help repair machines as well, like the 3D printers. So what I'm going to show you now is a brief snippet from YouTube. So if I switch to a different screen, and we'll just have a look at this for a couple of minutes. So let me share my screen to a different window. And hopefully this should work.
Yeah, Richard, I don't know if there's any audio in the video. But
I think is the audio not working?
Yeah, we cannot hear anything.
Ah, okay. Let me see if I can. If I select same as system microphone, does this work? Okay, so I'll tell you what, I'll talk you through what we can see. Apologies for that. I don't know quite why that's not working. So what we've got then is we've got our 3D printing society here, and then we've got our art sculptures club here. So they've made these snowflakes by laser cutting different bits of wood to try and give an artistic effect when you look from one end. The point is they've used technology to develop those. We've then got part of our second year integrated design or robot project. You can see that there, which students have built, and also our robotics team who do robots in their spare time. So we've got Kai walking through the Dyson Centre there. This is our structural design course, and that's where you build and make structures and test them. So you have to support 1/5 of a ton. And then we've also got here our autonomous air systems society with their fixed wing drones. And then here we've got BlueTap, which is a group of students for 3D printing parts to make nozzles for chlorinating water, so that in developing nations you can have water that's safe to drink. Here we've got our Full Blue racing team, our Formula student team. And so they sort of make an entry every year or 2 years into a competition where you have to build a race car and then actually race it. So it's quite an involved kind of process. You can see one of their old vehicles there, they've turned into a simulator. Not the only race team, we've got a solar powered race team as well. So these guys over here, they've got this solar powered race car. We've also got, let's say, the 3D printing society. They're like making things and also repairing 3D printing machines. They're obsessed with technology. And then space flight. These guys make rockets. So I've seen some fantastic pictures they've taken looking back on the planet Earth. They don't actually go up in their space rockets. They're unmanned, but there's some fantastic pictures. And there's other resources in here. So lathes and milling machines. And there's something you learn about in the first year of the course. And equally, teams that go out into countries to help people develop their lot in life. So the Cambridge Development Initiative is one example of that. So all of these teams are different teams that operate out of this area, and it's something which is considered a precious resource to us. And it means that you help to balance up a sort of a mainly theoretical course with some lab work, with some areas of project work, which you decide on how to do entirely yourself. So I'll move back to our lecture slides for the moment. Sorry about that. Just trying to find the share screen button. And I think we were about here. So, in terms of your schedule then, well, we've talked about lectures and classes and private study. And in addition to the timetable teaching, you also need to spend some time doing private or independent study. And you should expect to spend maybe 40 to 50 hours per week on your study. And so in terms of this, then it's something you're responsible for keeping track of as you work. But hopefully this does leave enough time to do extra things outside of the course, leisure activities as well. In terms of the teaching labs, so we've got various examples here, and the point of the labs is to reinforce the lecture material. So for example, when you do a course on structural engineering or civil engineering, then there are various mechanisms you might learn about as to how things fail and collapse. And so it's useful to do a lab to actually see these things failing and collapsing in real life in either model or miniature form. So the labs are there very much to enhance your lecture work. And then what happens is you get set a series of questions for each course that you do, a series of problem sheets, and you tackle these in something called a supervision. So this is what a typical supervision looks like, an expert in the field, maybe 2 or 3 students there. And it's kind of your chance 2 or 3 times a week to ask a different expert for their help with answering the question sheets that you've got. Now, I'm presuming that you're probably a good student at your school, and you might actually find that you don't frequently struggle with the work that you're given. The point with the Cambridge work is that you're all good students, and so the level of the work gets a bit harder to keep you interested and challenged. And so typically, I don't know what our panelists think, but for me, I tended to find as an undergraduate that I would be able to manage about 1/3 of an examples paper fairly okay. I'd have to struggle a bit to get my way through another 1/3, and I really couldn't do the remaining 1/3, and I needed some help from my supervisors to get through it. So it's important to have these supervisions, partly because the work level is harder, and also because it's good to sort of hear how an expert would solve problems. You learn a lot from them. In terms of our projects, so here are our first and second year list of projects that you might encounter in the course. To start off with, we have a Lego Mindstorms project. So in the first couple of weeks, you come together and you try and make some kind of creation that involves Lego Mindstorms to solve a problem. I mean, for example here is, because you get to pick what problem you want to solve. For example, is one team one year produced an automated pizza slicing machine. And of course had to test it a few times as well. For the structural design course, you work as teams to build structures, and you can see an example down here, people working away, and they typically have to support about 1/5 of a ton, almost a meter away from the wall in some way. Maybe it's a bridge, or sometimes it's a cantilever, a sort of single arm stuck out. There's also the integrated electrical project where you make something akin to a radio receiver. In the second year, we have the integrated design project, and this is to do with building robots to do a series of tasks. We've got one of those down there. And there's also an integrated coursework session, which involves several labs that look generally around the theme of the effect of earthquakes on buildings. So I've got a little example here of the kind of thing that you might do with Lego Mindstorms. So if we have a look at this, then I'll move over to this screen here. And so we don't need to hear the sound for this one. But what we've got then is it's a system where it's scanning all the different surfaces of the Rubik's Cube. And when it's finished scanning, so that's the 6th side it's done, it then works out how to solve this Rubik's Cube. And you can see the mechanism there manipulating the Rubik's Cube so that it can then bring it so that you get all the same colors on all the same faces. So this is an example of the kind of project that you could do in that first session, in those first 2 weeks. But it's equally something you could consider doing at home if you can get hold of or borrow some Lego Mindstorms kit. It's very useful for prototyping and testing out your ideas. So I'll just move back to our main presentation. In terms of your 3rd year and 4th year, then in your 3rd year, there's 2 main projects that happen. So they happen in the 3rd term, they happen after your exams. And in this case, you get to choose the kind of projects you do, but these are training projects almost. They can include group work, design work, field work, languages. And then in your 4th year, having learned from those 2 projects, you spend half your 4th year doing a major research project or design project, or it can be a project with industrial links. So it's your chance to put together all the skills you've learned over all the years. You might pick some of your 4th year modules to tally with what your 4th year project is, to try and give you some additional skills if you think you need them. In terms of industrial experience and gap years, we require all our engineers to do at least 6 weeks of certified industrial experience before the end of the 3rd year. And this is work of a technical nature, and it sort of involves things that you may have studied or things that you've learned something about, but you get that knowledge extended further. Equally, your pre-university placements, if you've taken one, they can contribute towards that 6 weeks. And we've got an industrial placement coordinator. She can help students find places. She can actually help people find places even if they're only in the application process, the university as well. So if you're interested in a gap year, it is worth getting in touch with her. And so the kind of things you could end up doing research work, doing experiments, preparing reports, presenting findings, analyzing production processes, so you can maybe recommend an improvement. And that's not an uncommon thing to happen. People frequently put together their production process and it's all a bit last minute and they finally get it working and then they're out of time and they have to move on. And actually you as a student coming in, it's an interesting project to put you on where they can say to you, how do you think this is made? Now go and have a look how it's made. Now see if you can spot that there's an issue there. So one of our students in one summer, a fair number of years ago now, ended up contributing to a project which resulted in the attaching of brake lights onto the rear windscreens of vehicles. And so you'll see that in a lot of cars at the moment. And so they played their own small part in that process and it coming into being. And now you see that on a great many cars in the road. Equally, you might be involved in checking design calculations. You might be helping with software development or testing products. In terms of accreditation, Our degree is recognised by all the main engineering institutions, for example, the Institute of Mechanical Engineers, but equally there's bodies such as the IET, which represents sort of the whole range of different forms of engineering. But they all accredit our degree as long as you've taken sufficient number of modules in their area in 3rd and 4th year. In terms of the engineering societies and their extracurricular material, extracurricular activities, you've seen a few examples of that. We also have teams that build submarines. So you can either see the swan there, just gently scrutinizing the submarine to check that it thinks it's up to it. We've got our solar race car here at the end of the race in Australia, where they go to every 2 years. Equally, our robotics team gets involved in Pi Wars as well. So a whole range of different activities there. And what will you get overall out of this? Well, you'll get specialist skills and you'll get transferable skills. So broad scientific and engineering education, in-depth knowledge of specialist subjects, but also problem solving and team working skills, a creative approach to your scientific and mathematical problem solving. And you'll get mathematical and computer skills, research and data skills, communication and presentation skills as well. It's not all about work though, as we've said. So it is also about living in Cambridge and enjoying what's there and taking advantage of these different things. So it's important that you sort of plan and balance your life carefully in this way. There are a great many opportunities there. The societies, the events that are going on, and the people around you that you'll meet, you know, you'll find many, many like-minded people and enjoy their company as well. So, one thing we've not really said much about is the colleges. So, how do they fit together with the university? Well, for an engineering degree, you do your lectures and your seminars and your classes at the engineering department. Also your practicals, your labs and your projects. They might organise field trips and language courses, and you sit all your exams at the engineering department. In terms of the college, well, all of your supervisions for 1st and 2nd year are organised by your college, by people chosen by your director of studies, who's responsible for your academic guidance. And also your college provides someone called a personal tutor, and that's someone who's responsible for your non-academic requirements. So if you have financial problems, if you have personal problems, that kind of thing. But so there are these 2 key academics, 2 fellows within the college who are people you will get to know over your time there, hopefully. Now, I said that I'd mentioned something about opportunities for graduate engineers. So where do our engineers go? What happens to them? Well, there's a few examples here. So one local company is Cambridge Medical Robotics. There are many other similar companies to this. And a number of people will go into areas like this, where you're combining mechanical engineering and you're combining electrical engineering, electronics, software engineering. And the aim for this sort of company, well, this particular company, is they want to provide surgical robots that can be operated by doctors. So it's not that the robot goes away, starts doing things by itself, but the point is that via using screens and these robots, the doctor can operate via keyholes, even for surgery where that wouldn't normally be possible. So that enables much faster recovery times for people and much less chance of infection. So you're benefiting sort of people's lives with this kind of technology, but it is equally robotics, which is something which is much interest at the moment. Another place where some of our graduates go, companies that go and try and help people out in developing nations. And one of these is, curiously, Blue Tap. There was a student society that I showed you briefly a few slides back. And in their case, they're 3D printing low-cost water purification technologies. And they went from being a student society to now being self-employed and running this now as a going concern. The civil engineering, for example, there are many large companies that are involved in civil engineering. One of those is Mott MacDonald, and here is one of our former students, Benali Ghosh, and actually now she's got to the stage where in July of this year, she's been appointed as a visiting professor who'll be coming back to the department. So that's a good outcome from my point of view. I knew Benali before that happened. So there's many different opportunities out there. If you're not quite sure where you want to go, consultancies are sometimes an interesting way forward. because they're nicely varied work. You do a range of projects that run from a few months to a few years with them sometimes, and so you get to change your role and change what you do, change what project you work on. And an example of this is a company called TTP, Technology Partnership. But equally, there's a great many careers out there, some of them that aren't immediately obvious. So a number of people I know of have gone on from here to become pilots. Equally, you could go into banking. I've heard of people going to medical research as well as a result of their engineering degree. The options are fairly limitless. It's more down to your imagination, really, as to what you might want to do. In terms of perhaps a more formal breakdown, so got a pie chart here. You can see here we've got examples of further study, research, teaching, social related things, public service, arts and recreation, publishing in the media, legal. And if you think about things along the lines of people submitting patents, engineering patents, then they need legal support from people who are legally qualified, but also engineering qualified as well. We've got accountancy and tax, and that's sort of less to do with engineering, but it might be using on mathematical and problem solving skills. So banking, management, consultancy of various types, IT, manufacturing, and various bits of service industry. And one thing that isn't important here, and that is how much you end up earning at the end of it. It's nice to have enough money that you don't need to worry about money. That's a useful way of putting it. You shouldn't necessarily go and get a job though just because it's a big packet of money. Because if you're doing something you hate every day, then actually that isn't necessarily worth particularly much money, because you spend the majority of your life in some senses at work. I mean, if you ignore the sleeping part as well. So the average starting salary in 2016 of a Cambridge graduate was £33,000. I'm sure that kind of recent coronavirus related things will cause a hiccup in the starting salaries, but I'm sure at some point after that they will recover fairly quickly. But this is the kind of levels of money that you're looking at. And then briefly to touch on engineering research. So we've already looked at some examples of engineering research in terms of the areas. Research is one career that people can do. It can be with a company, or it could be at a university doing a PhD so that you end up becoming Dr. So-and-so. And research is about blue skies thinking. It's about looking, say, 20 or more years into the future. Whereas most companies focus on the present and the next 1 to 5 years. And actually most companies at the moment are probably looking moderately short term to when they can actually make some money again. So there is an issue. I mean, there is a gap there, what happens between years 5 and 20, and that is actually slightly tricky to manage. So it's important there that governments provide money for companies to allow them to focus on that sort of slightly unprofitable area, because they don't get any return for many years on that. And also that they support universities so that we can be looking 20 years in the future, because we're not going to make any money out of those things, not in the recent time anyway, not for another sort of 10 or 20 years. So in terms of what I did as a researcher, in my case, my research was to do with heavy trucks. And the relevance of heavy trucks is that actually if the Earth's resources start getting scarce and there's not enough not enough fuel around so that we can all drive cars around the place, well, the one thing that you will still need is trucks, because you'll still want to get food from your local supermarket. You'll still need the rubbish taken away from your home, even at the point when we can't afford to run cars anymore. So they have their importances. Here's an example of a truck which we put a system on so that it could tilt into bends. You can see on this right-hand side picture here, the truck is actually tilting even though the table is flat. And then having tilted the truck by itself, we then tried tilting the table it was sat on to see how long it took before the truck fell over. Curiously, there's a series of straps over the top of it, and there were actually 2 very large people on this side, and just at the moment when all 40 tons of truck was about to fall over, they would jump on the straps, and because it was just balanced so finely, the weight of 2 people was enough to stop it falling over. At least that was the plan. That's what happened. It did work, but it was a little bit exciting for those few seconds. What I've also got here then is some research which I did on vehicles where the wheels of the trailers steer. So the back of the truck steers, not just the front of the truck. And the benefit of this, the reason why you do this is you make the truck more maneuverable, and that means you can make the truck longer. And the longer and larger you make the truck, the less energy it takes to transport goods from A to B, because the less proportion, the lower the proportion the weight of the truck makes up of the load of the entire thing. So in other words, for this massive truck here or this massive truck, there's less weight of truck per ton of material you're transporting than this truck here. And actually from the picture, you can kind of see that that might be the case. So the aim here was bigger and bigger trucks, but to make the trucks bigger, we had to make the wheels on the rear of the trailer steer to make it maneuverable. So here you've got, for example, a standard size truck. It's just going around a roundabout, just fits. It's just about to touch the island on the center of the roundabout. And if we have a longer truck, unfortunately, it drives right over the flower bed. So you end up getting in trouble with the police and the local council gardeners if they spot you've ruined the flower bed on the middle of their roundabout. But if you add steering to your truck, you can make the rear of the truck move where you want. So you can easily make that larger truck fit on the roundabout. So we talked about the different areas of research that other people had done. I've shown you the bits that I've done. And so what we've got then is hopefully a complete picture there of everything to do with being an undergraduate, what happens if you stay on with research with us, and what happens if you don't stay on to do research, what happens if you go and do a job outside of the university. So thank you for listening, and I'll leave on the screen just for a moment or two a few examples of where you can find out more about this if you want. The university's website on admissions at the engineering department, the university's website on admissions on its own website, the page on its own website. There are also links on the same area to do with finance and living costs. And an interesting one to look at is iwantostudyengineering.org, which gives you plenty of questions to help you brush up on the kind of skills you might get asked at during an engineering interview or during an engineering admissions test. And if there is anything on there that you don't know, that you want to find out from the university, there is also an admissions email at the engineering department. And also you can contact Sergio at the admissions email at Magdalene if you want, or in fact, we'll probably talk a little bit about how you pick a college in general, and all colleges have their own admissions office. So if it's a college specific question and you know which college you want to apply to, then you should try and contact them directly, perhaps, to find out. So thank you for listening, and I'll stop there.
Well, thank you very much, Richard. That was a very good introduction. Very nice overview of what it's like to study engineering in Cambridge and engineering in general. And yeah, I learned many new things I didn't know. I wish I was a student in engineering now and I could go and use those design labs. So it seems that we have already one question from the audience. So I'll take this chance to encourage people to ask any question that they might have. There are no wrong questions. So maybe let's start with the one that we have. So someone asks, for someone interested in the engineering of high performance racing cars, what would be the best route? So, if you wanted to be in a Formula One team or to start the next Tesla, what would be the best course? I don't know if Richard, if you can comment on it.
So there is probably no wrong answer to this, in the sense that if you go through the degree, then you could apply then. You could, whilst you're doing the degree, try and get work experience there, and I've known people do that. I've equally known people stay on and do a PhD and then go into a race car team. And I've equally known people who were lecturers here who decided they wanted something different, and they actually went and worked for a race car team. So in actual fact, there's quite a quite a representation of Cambridge engineers at McLaren, but also I know of people at other race teams as well. So it's, if you want to get into it, then there are many routes to get there, many routes.
Okay. So then we have a question about whether projects that are in the 3rd and 4th year are accounted for in the final grade. So how does that work? I don't know if perhaps Richard or one of our students can comment on that.
Does someone else want to answer this one? Change from my voice?
I think I don't know how many of you are in your 3rd or 4th year.
I'm in my 4th year, and I think Odu and Ali are in their 3rd. So for your 3rd year projects, it's a bit tricky. Basically, when you graduate from Cambridge, at least for me, I'll get a certificate saying I attended a graduation ceremony at Cambridge, and then you get a transcript with all your grades for all years. For 3rd year, your projects do come up on your transcript, so you have a grade for all your coursework and your projects show up there. In terms of your 4th year project, which is your master's thesis, basically, that accounts, it's half of your year time, but you get the lowest of the 2 grades between your exam results and your 4th year project work. And given it's a master's project, it's not first class 2-1 etc, which is the normal university grading system, but it's master's project, so it's distinction, merit, pass, which is, I guess, similar to some BTEC things for A levels. But yeah, so you get that rather than, so either or, depending on which is lower of your project work and your exam work in 4th year.
Very good. Thank you, Areeg. So we have a question about what do people who become pilots tend to do after they have graduated? So I think I would say that becoming a pilot is more something that you do after you graduate, right? It's not something that you can study for specifically at Cambridge. Is that correct, Richard?
I mean, it would be specifically that you would apply to actually start doing the training. And there's a range of different areas there. I mean, for example, if you go to the sort of major companies that employ aircraft, like British Airways, and that they would have schemes for taking on people to train as pilots. Equally, you might have got involved in some kind of cadetship while you're here at the university, so as something that's extracurricular. And so that might have given you a little flying experience then, but there are various different ways of getting into it.
Okay. So this is a good question for students. For the undergraduates, is the workload overwhelming compared to A levels? I don't know which one of you wants to. Perhaps we can hear from Odu.
Yeah, sure. So if you get into Cambridge, chances are you're probably pretty smart, and so the workload at A levels would be, manageable. You can get by without doing too much work. And it is very much the case that when you get to Cambridge, I think, as Richard said, the work gets harder. You get an examples paper, and there's about a third of it that you can do, and the other 2/3 you will be, hard pressed to actually complete. And for many students, they would then spend the entirety of their night, and I'm talking to like 3 a.m., trying to solve those questions that, quite frankly, it would just be, very difficult to solve. So yes, TLDR is that the workload is a lot higher simply because it's a lot harder, the work. And so you can decide how much time, to an extent, you could decide how much time you want to pour into your course and how much of it you want to try and, be more, probably a bit more sensible and, maybe talk to a supervisor for help as compared to staying in the library till ungodly hours. So yeah, the workload is a lot heavier at Cambridge than at A levels, I would say.
I would like to add to what Odu is saying, like most students that end up going to Cambridge were actually pretty good compared to students in their school. And I think one thing that I found personally quite challenging is being quite mediocre, or in fact below average, when I came to Cambridge. And that can be quite a hit to the ego. And you learn that in first year, actually, it's okay not to be the best. It's okay not to know the answer. And I think this can sound quite scary, and I promise we're not trying to scare you, but it's just, I believe we need to give you a clear image of what you're signing up yourself for. I think someone told me you work hard to get into Cambridge to continue working hard. And I think that feels quite right. But it's enjoyable and there's always help. So that's okay.
I guess the key thing to remember is that everyone will be going through this kind of experience, or most people will be going through the same experience. So it's definitely something you can share with others. Ali, I don't know if there's anything that you would add to that.
I think for me, the main difference I found was kind of the time frame. So in Cambridge, the terms were a lot shorter, whereas in A-levels, you kind of have like a 40-week whole year to kind of just go through all the content, whereas in Cambridge, it's very short, kind of intense of 8 weeks. So I kind of found for myself that I kind of had to do some sort of like almost catch up during the holidays, trying to not necessarily go through what I missed, but kind of like make sure like everything sat with me correctly, because the time just felt like quite short to me, and I feel like that's what made it a lot more intense, kind of the time.
Yeah, I think that's definitely true for teachers too at Cambridge. So someone asks a good question. So if you do not take further maths for A-level, are you at a disadvantage in terms of getting a place and the level of difficulty of the course? So I would say further maths is highly recommended for students that are doing engineering, but it's not a requirement. And we, from the point of view of admissions, we are definitely aware that not every school in the country provides further maths. So there are certainly many students who have not taken further maths at Cambridge, but it is recommended. I don't know if there's anything that you might add, maybe the students from their experience.
I think you would like to look at different colleges' admissions, because I believe Trinity requires you to do further maths, and some colleges such as Christ's and Peterhouse also require you to do step maths, which is another mathematical qualification. So with those, I would look through the admissions. And in the experience of the course, I personally did further maths, but I didn't have a teacher. So I ended up self-teaching further maths, and I learned how to answer questions for A-levels rather than actually learning the maths. And I ended up really struggling in my first year. So in first year, the first term of maths is helping everyone catch up to the same level of mathematical knowledge. But if about 50% of the course, actually there's two streams of maths. There is fast maths and standard maths. Fast maths is faster in that they're just brushing over the content. It's kind of a reminder, whereas standard maths goes through the things in detail. But familiarity with it would really help. But also the department gives you questions before you join, preparatory problems to help you see what is kind of expected. So things like matrices, if you had never come across them, you're actually given a chance to go through them before joining the department. So I wouldn't fret if you can't do it, but if you have the ability to at least do an AS in further maths, that would be quite useful.
If I could just add to that completely, so it's very much the case that you have two math streams, fast and standard. So even if you haven't done further maths, you will still get a chance to explore a lot of topics that you might have missed out on. But that being said, if your school doesn't offer further maths, I think it's very advisable to try and spend time during the summer before arriving at Cambridge, because people always ask, what can I do during the summer before arriving to get ready? Right, so if you haven't done further math, there's a lot of online resources, right? Khan Academy being a very prominent one, I think Udemy, and there's just a wealth of online tools to learn and self-teach, like, Areeg did lots of different things and different subjects. And yeah, that would be very good, because the thing with maths in particular, besides all the other modules, math is that one thing that kind of comes up again in every single module you do, from mechanics to information to structures. And so it would be useful to have more than just I did this, maths module for 3 weeks in first year. but to have a deeper understanding of it from having done it, during summer and then reviewed it during first year and so on and so forth. So I think it would be useful to have some exposure to further maths before arriving at Cambridge, just because of how ubiquitous it is and how it turns up literally everywhere in the course.
Thank you, Odu. I think that's excellent advice. And this actually reminds me of a couple of resources that I'd like to point out to people. So I'll very quickly share my screen with you. And I want to point out just one website. I don't know if you can see this. It's undergraduate.study.cam.act.uk/courses/engineering. I hope, can someone confirm that that everyone can see this? Okay.
Yeah, that's up there.
So here there will be a tab called entry requirements. And so one thing that Areeg mentioned is that different colleges may have different requirements. And so, for example, here they list that some colleges require a higher level in a third science or math subject, or STEP, which is a specific maths exam that is run by Cambridge. And in this file, you'll find a list of, so if you click on this link, you'll find the entry requirements that are typical per college. Okay, and so this is an excellent resource for selecting a college if you are applying to Cambridge in engineering. And then on the topic of that Odu mentioned, and how to prepare for during the summer, if you haven't had the chance to take further maths, there are some resources like ISAC Physics, which is prepared. This is a program that's developed in Cambridge, which has some enrichment materials for A-level maths, and some of which is specific to engineering. So this is something to take a look at. And also Enrich Maths is another program that is developed in part in Cambridge. And it could be something you can use to further your math skills before you come to Cambridge. It's also an excellent way to prepare for admissions interviews and pre-admissions assessments. While we're in this website, before I stop sharing my screen, I just wanted to mention that there's also some information about the pre-interview assessment. So this is an exam that happens at the beginning of November for applicants in engineering. And there's a great list of papers from previous years that you can use to prepare. So if you're applying this year, it's something that you should be working on. But if you're in year 12 and you still have a year before you apply to university, this is the type of information that you'll want to collect as you decide on where to apply. Okay, so I'll stop sharing my screen there. I hope everyone had a chance to copy the URL. And I should say that I will try to post a video of our session today, so you can always look back at things that we've said if you haven't had a chance to copy something down. So Minahil asks, if you're applying for chemical engineering through the engineering route, should you make your application specific to chemical engineering or not, such as your personal statement, for example? That's a very good question. I mean, I think if you're sure that you are interested in chemical engineering, it would probably make sense to apply directly to chemical engineering, because then your interview would be specifically focused on chemical engineering, and especially if you have taken chemistry at A levels, that may be a good idea. But if you apply to engineering, that leaves, I guess it gives you slightly broader options. Do you think that's fair, Richard?
Yeah, so I mean, what will happen typically if you apply for chemical engineering, then you'll probably get one interview with some chemical engineers and one interview with some engineers. If you apply for engineering, you'll probably get all your interviews with engineers. So it depends really, I think, how sure you are that you want to do chemical engineering or not. If you still want to keep your options open, maybe you apply for engineering. If you're definite that you want chemical engineering, then it's worth applying from that point. The only downside to not applying for chemical engineering is that if they run out of places priority goes to those who applied for it. But to be honest, they have a new department, and I don't, in 26 years, ever actually recall them running out of places. The same isn't quite true, for example, manufacturing engineering, where actually they do start to run out of places these days. Its popularity has gone up in the past few years.
Thank you. Another person asks, in the last 2 years of specialization, would you cover the same depth of content that you would in a 4-year course in a specialized degree at another university? It's a very good question, because other universities tend to offer degrees in specific types of engineering. So you can go somewhere to study specifically mechanical or civil engineering. So what would you say the difference is between a course in Cambridge and a course in another university would be?
Is that helpful if I comment on that one?
I think you may have the best information.
So the point is that different forms of engineering actually have a surprisingly large amount in common. Things that you might learn in electrical engineering, some of the mathematical skills, some of the techniques are applicable to other forms of engineering as well. And so what you're learning in your first and second year isn't so much 10% of one type of engineering and 10% of another type of engineering. What you're actually doing is spending about a quarter of your time learning maths, in the same way that you would in most other courses, a large portion of time learning maths, and then learning techniques that are transferable between different forms of engineering. And then when you go into your third and fourth year, actually, we do cover a bit more work here than at other universities. And so overall, the third year plus the fourth year, plus the content you've learned in the integrated 2 years, plus all the maths from the integrated 2 years, means that you have learned a comparable amount of information, but you've also covered all the different forms of engineering as well in a sort of slightly more broader sense. So it sets you up perfectly for either being a specialist or being a team leader.
Wonderful. I don't know if some of the student panelists have, maybe you've had friends who are studying at different universities. Would you be able to compare Cambridge to other places that offer specialized degrees?
I think personally, this is at least, I remember talking to a friend who did mechanical engineering at another university, and the amount of mechanical engineering that we had covered in the first 2 years, besides everything else, was a bit more advanced than what they had covered in the 2 years, which was a bit shocking to me. But yeah, I think this is not necessarily the case for aero. I think a lot of my friends who wanted to do aerospace or aeronautical perhaps consider other universities just because they think that would have changed. But from what Richard was saying, I don't know if that's necessarily true. But at least for what I'm doing, information and computer engineering, I would say information engineering wise, we do cover quite a lot of depth. I think Cambridge is really good at getting in a lot of depth in a short amount of time. But yeah.
Yeah, and if you don't mind me just commenting here as well, I think one other thing is just frankly, we probably just do more work at Cambridge. Double-edged sword, either love it or not, but it ultimately means that we cover more content in the same amount of time, because I have friends at Imperial and other universities where we would meet up and we would talk about our weekly kind of schedules and work routines, and it's sad to hear when you sometimes hear them talking about just how much time they have for extracurriculars, and they start asking me, so what have you been doing as far as stuff outside your course? And I look at them and I say, outside my course? What? So yeah, I think we do just spend a lot more time and a lot more work on the course in Cambridge, which means that despite us doing more stuff in the first 2 years, it balances out because we do, like I said, just spend more time on the course, and so it doesn't equate to us being less advanced in our respective degrees than people who did their courses and just those since year one.
I'm glad there's no one from Imperial College in this webinar to defend Imperial. Okay, so what would you look for in a personal statement for computer engineering? So maybe this is something that Richard and I can answer. I don't know if Richard, you want to start?
So, I mean, the general point is, I guess, that when you're writing a personal statement, you need to convey enthusiasm for the things that you want to do. So you want to make clear why you were interested in in the computer side of engineering. And do you in that sense mean information engineering, or do you mean software engineering, or do you mean the electronics side of it? And maybe you mean all of them, or maybe actually you're not yet sure. But the point is there'll be some things that you know you're enthusiastic about, some things that you know you like about. What things have you done to confirm that you like that? For example, have you tried building your own miniature computer or programming an Arduino or Raspberry Pi? Even something like the Lego Mindstorms video, where it's a computer that is scanning in information and then working out where all those dots actually are on the Rubik's Cube, and then working out how to manipulate it so they end up in the right place. That's all part of a computer algorithm. So some evidence that you have tried to investigate, tried to look further, you demonstrated your enthusiasm, and that process applies for any particular branch of engineering.
I think I think another, I would say, general advice that I would give for personal statements in technical subjects is we want to see beyond just curiosity about the subject, that you have engaged with maybe a specific problem in some detail. So perhaps if you're interested in computer engineering, perhaps you can show that you've tried to learn a computer language, or that you enjoy tinkering with old computers, or maybe you had an experience at some point of working, participating in a lecture about robotics, and there was something specific that interested you. Or even some, enrichment activities in mathematics. So maybe you spend part of your summer taking advantage of some courses online that you found interesting, and there were specific problems there that you can discuss in some level of detail. I think that makes a personal statement stronger. Alexander, so I know that you are someone who works with many students, helping them with their personal statements. Is there something that some general advice that you could offer to someone writing a statement in engineering?
Always be specific is the sort of overarching advice. You never want to be too general about what you've done. You always want to talk about specific things that you found interesting, or specific things that you did. Maybe you was part of a group project that you were taking part in, but you always want to sort of really go into detail. You always want to try. That's sort of how you sell yourself to Oxford or Cambridge, by really expanding on what you've done, because that shows any admissions tutor reading your personal statement that you're actually interested in engineering. So if you feel like you need to simplify anything, then don't. Someone who understands your subject will be reading it, and so really go for it. Try and fit as much detail as you can in with those 4,000, with that 4,000 character limit.
Thank you. Sorry, Areeg, did you want to add something? Or no? Okay. Okay. So Yoshan asks, what are the typical GCSE grades for Cambridge students? So that question is something. It's a bit difficult to answer, because when we look at your application, we consider your GCSE scores in the context of the average levels in your school, and other circumstances, other aspects of your application, like the personal statements and teacher recommendations. So there's not a specific standard that is required from all Cambridge students, but I would say that most successful applicants have about, at least 4 or 5 subjects in the 8 or 9 grades, and sometimes more. But yeah, I mean, we look at the whole application, and then if you're invited to interview, you have to bear in mind that we invite we receive many applications and only a fraction of those get deselected at the first stage, and then students interview, and then a subset of those will get an offer. And so the interview is also an opportunity for you to show your talent. And we also have the pre-admissions assessment for engineering in particular. There are many components, and so the GCSEs are just one piece of the puzzle. So Grace asks, I know that further maths isn't required and is only strongly recommended, but does this mean that one will be severely disadvantaged during the application process if they haven't done it? I wouldn't say you would be severely disadvantaged. So for example, any student who is in a school that doesn't offer further maths, as long as we see the potential to do well in the engineering course, they would not necessarily be severely disadvantaged. Yeah, and I meant we've all mentioned that there are many students in the engineering course who haven't done further maths. So I think that that's certainly not a severe disadvantage. Richard has something to add here.
So one thing where it is perhaps curious, one thing where you might first come across anything where you wondered if that was the case would be the admissions assessment. So what I would suggest is on that page that Sergio showed us, there's a specification for the test. Now, specifications are normally slightly dry documents that aren't normally sort of something we bother reading for exams. But actually for this one, the specification for the admissions assessment is actually a list of everything you sort of assumed to know. So you could have a look through that list and see if there's anything that you don't know on that list. Now, if there is anything you don't know, you could actually consider spending a few weekends between now and when you take it and see if you can learn one of those skills. It's something you could briefly mention in your application paperwork, or after you've applied, you'll be asked to fill in a questionnaire. So you could mention in that. And if you did sit the test and you found there was a question you couldn't answer because you'd not covered a topic, maybe it would be a good idea to actually email in and tell the admissions office for the college you're applying to, and just highlight to them that actually there was a topic that you didn't recognize. In. Equally, when you sit that test, there are a lot of questions in that test. People don't score near 100% normally in that test. The average mark is about 50%. It's a hard test. So in other words, if you come across a question in there that you don't recognize, I would just move on and go to the next question and don't worry about it. If you want, you could even try guessing the answer and move on. So as you've got, maybe a 1 in 5 chance of getting a mark for that question anyway. But so this is sort of a two-way process. In other words, if there's things you need to tell us, like I don't really feel like that was quite fair because there was a question I didn't know in there, then tell us. In terms of the questionnaire, you list what topics you've already done in your subjects, so your interviewers can see the topics you haven't done, so that they can avoid asking you questions about those topics that you haven't had a chance to study yet.
Yeah, that's very true. Yes. So when you look at the exam specification for the admissions assessment, it can be kind of overwhelming. It's a very long list of subjects, and it's possible that some of these things are things that you will be studying this term, or that you won't have seen because you haven't taken further maths. But it's important to keep in mind that the average score is 50%. So there are many questions that you could skip in the exam. On the other hand, the earlier you look at those documents and come to grips with which subject will be covered, what you should review, I think that the better your chances. So I would encourage everyone to go take a look at that soon. Okay, so Niall asks, what are the best extracurricular activities, hobbies, etc., to do in order to prepare for an engineering course at university? I don't know if one of our students would have any suggestions. Areeg.
I think my answer for that would be, given it's a hobby, something you like, because basically do things you love and they'll take you where you want to go, whether that's engineering or not. Because I don't know, if your target is an engineering degree, find something that you enjoy. there's a lot of things online. Personally, I did nothing related to engineering before coming to the degree. I barely do any extracurriculars related to my degree, and that's okay. I'm still at Cambridge and still doing engineering at Cambridge. But part of your personal statement, you want to show your passion for it. And actually, if you can't find things that you're passionate about or you found interesting on the internet, and also a note, it's okay if your school doesn't have resources. Like my school did not provide me with any support. I just found random articles online that I found intriguing. So yeah, if you don't find things that you find very enjoyable about engineering, actually, you might want to reconsider whether you want to take the degree to begin with. Again, it's just basically you're choosing a thing for the long term. But things I would suggest personally, given I do computer engineering, learning a bit of Python. Python is the main coding language the department uses. It's quite useful. And it's a lot of mind games, really. It's just like cool logical problems that you solve by telling computers things to do. Or there's like a lot of online things that you can, like online games and stuff that play like are mentally challenging. And if your school has like a maths club, join that, or a physics club, or if you can find pieces of wood and put them together in a way to make a contraption, do it. Just like anything that brings you joy and makes you happy while you're doing it, actually, that'll also be an indicator, because in addition to you wanting to impress Cambridge, you want to know whether this is something that you want to do, and actually trying these things out will help you know that.
There are wonderful resources for learning Python. So if you go to Code Academy, they have courses that are completely free, and they just happen in a browser. So you only need a computer, it's it's an excellent type of extracurricular activity to do for engineering. Odu, I think you looked like you were about to say something.
Yeah, I was debating whether or not to add to this. So what Areeg said, 100%. Like, I know getting to Cambridge is like the grind, and so you want to do whatever you can and you must to get here. I mean, I think you really should just think about what you enjoy. If they are having, you attended physics club and you just didn't resonate with you, and all signs are pointing, elsewhere, then don't ignore that. But that being said, if you're sure that engineering is for you, then I think the kind of clubs you want to do is anything that indicates your interest. Anything that if an admissions tutor, like Richard, were to read, they would think to themselves, "Oh, that's interesting. This candidate is doing this really cool thing related to engineering." And so that could take a variety of forms. That could be learning Python in your spare time, and programming all kinds of cool, a rock paper scissors game with the little bit of Python you learned, right? That could be starting some kind of science and innovation club at school, where you and your friends all learn about the kind of cool things that are happening in the engineering world, the most recent developments in the world of nuclear fusion or something, and those kinds of things. And obviously do whichever one tickles your fancy the most. And so, yeah, but ultimately, I think that's the general idea. Anything that indicates to some extent your interest in engineering, your genuine interest in engineering, would be a good thing to explore further.
Great. Thank you, Odu. Okay, so maybe we can move on to a new question. So would employers prefer a degree in a specialized field of engineering compared to a general engineering degree? I think the university that you come from could be as important as a degree of specialization. So I wouldn't say it's a disadvantage to have a general engineering degree from Cambridge relative to a specific degree from another university. So we've talked about the differences in terms of the level of depth that you go into, but I think the name of the degree is not a disadvantage. Is it something that you would agree with, Richard?
Yeah, I mean, it's worth sort of saying that it's not that it's general, it's more that it's integrated. So in the sense that it's a range of different forms of engineering you're looking at. So when you're going to a company, is that company going to prefer someone who has just a specialization, but they can't see anything else? Or is that company going to prefer someone who's got specialization and a broad range of other skills as well? And I think that's where you're coming at it from. And when you view it like that, it's hard to see that if you had two comparable people, that they wouldn't opt for the person with the slightly broader range. The only reason why they might not is if they were worried you might get bored. And if they're worried you might get bored, then I'm not sure you necessarily want their job.
I think I would also add, personally, what I've realized is my engineering degree has helped me learn how to solve problems, and problem solving is in the job training, because most jobs have these very niche things that no one has covered at university, but actually having a Cambridge degree and having insight into different fields and problem solving in different fields can actually be quite a useful thing, because that means you're a quick learner, you can adapt to new situations. And given the current atmosphere, there's a lot of change, so companies are actually needing to be adjustable to change, and actually you having a wide range might be a useful thing.
Great. Okay, so Yoshan asks, would students with 4 A levels have a higher chance of getting into Cambridge? So, I mean, I would say from an admissions tutor perspective, having 4 versus 3 A levels, we're not very sure how to judge that when we look at your application in December or November, because we don't know how well you're going to do in your A levels. And on the other hand, most of the conditions that we put on your offer are based on just 3 courses. So in the case of engineering, I believe we require, most colleges require 2 A stars and 1 A. And so I think, I don't know what the best strategy is. I mean, obviously, if you take 3 courses and you can spend more time studying for each course, and you're more likely to do well in each course. But if you do 4 courses, then maybe you have a slightly higher chance of having at least 2 A stars. But then you get the trade-off is you have less time to prepare for each subject. So it's a personal decision. I'm not sure what is most common. Richard, your impression?
It's quite a mix, actually. It's quite a mix. And the curious thing is that if I was to look through the range of different schools we see, then the majority of the private schools tend to send applicants to us with 3 A levels, because I think they figure that actually with 3 A levels, you might have the highest chance of getting the highest grades in those. And curiously, those with a large number of A levels tend to be from state schools, where actually the student has almost overruled their own teachers, and they've pushed through and said, I want to do this many A levels. So I do have one friend who did 8 A levels, and that is too many A levels, I think. If you actually Google them, you'll probably be able to find the person on the internet. The point is, I think you need to make sure you're doing what you can manage. 4 good A levels will look better than 3 good A levels. But if you're going to do 4 A levels, you need to have what I would refer to as a regular meeting with yourself, and you need to decide if you're happy with what you're doing. And if you find you're struggling, then you need to carefully back out of one of those A levels and just stick with 3, because you might be capable of doing very, very well at 3, but 4 might be too many. So you just need to carefully weigh up what you think you're capable of and what you want to do, and whether you want to do the subjects, which is a good point that Areeg made. You want to make sure you're happy with what you're doing.
Okay. So we have about 5 minutes left for questions. So maybe let's try to run through a few of we still have 6 open questions, if we can try to quickly answer them. So someone asks, what supercurricular and work experiences did you do? So this is a question for a student. So maybe if you can very briefly describe the types of supercurriculars that you did. Maybe we can start with Ali.
I think for me, before I came to Cambridge, the main things I did were like a little bit of programming, and then I had kind of like one main project in like renewable energy that I was interested in. But I guess, yeah, it's generally just doing, I guess for people trying to like improve their university application, I'd say to find that middle line between what kind of might benefit your application and what you enjoy. But I'd say definitely the main thing is something you enjoy. So for me, it was kind of sustainability and renewable energy and stuff.
And Odoo?
So for me, I did a lot of independent research. So that was going into YouTube and watching videos on how jet engines work and how tokamak nuclear fusion reactors work. It was an area of interest for me. So that was one of the things that I did. The other thing I did was I started a club, like I think I mentioned an example I gave earlier, where my friends and I got together just to talk about the kind of cool scientific, futuristic Star Wars looking things that we've been, researching into, so we can just talk about it with each other. And the last thing I did, which I actually I got quite involved in, was debating, which on the surface doesn't seem too related to engineering, but there's a lot of problem solving involved when you're given a motion, as it's called, and you are asked to either oppose or support it, and you're given 15 minutes to prepare for a 1-hour debate. So yeah, that was very problem solving related, and that was one thing I did during my A-level years. And so yeah, they were quite fun.
Great. Thank you. And Areeg, you've already said something about what you did.
Yeah. My work experience on my personal statement was reading an article and working for a bit in a hospital. And I related that to I realized technology is pretty interesting in the health sector, and I want to be able to help people in that way. Like, I just realized being a doctor is perhaps not the most efficient way to help or save people's lives. If you make one device that hundreds of thousands of doctors use, then you can have a larger impact per human. But yeah, that's how I viewed it.
Great, thank you. Okay, so how would you suggest we prepare for an interview, and what do you look for during them? So I think preparing for an interview, if you're well prepared for your admissions assessment, that will definitely help you at the interview. The main thing to remember in the interview is you're not expected to do every problem that you're presented with. Your interviewers will try to give you problems of increasing difficulty, and at some point you'll invariably get stuck. And what the interviewers are trying to gauge is how well you would do in a supervision setting, if you're able to take hints and continue working through a problem that is a struggle. And I think it's a great idea to look at many mock interviews that have been recorded and are available on YouTube. So if you Google Cambridge interviews, there are some videos that are produced by the university that can help you familiarize yourself with the format of the interview, and that'll just help you decrease your stress levels when you arrive, and that's half the battle. It'll also, you'll also get a better idea of the style of problem and how a problem might be structured.
Could I add that one thing to remember during the interview is speak out loud, and especially this year interviews may be remote, so practice speaking to someone about cool, challenging stuff online, because that can be quite off-putting to some people. But remember, a person can't tell what's in your head if you don't tell them. So remember to talk out loud, and just remember the interviewer is also there trying to help you make it to Cambridge. So you're both on the same side. So chill and breathe. Yeah.
If I could just add one more thing as far as preparation goes. A lot of people want to know what kind of questions they can do to prepare for, the questions they'll be asked in their interview. I think it's important to realize that the answer is not A-level questions, and it's quite a strong opinion I've had on this. A-level questions can be quite formulaic in their nature. It's very much just switching out the numbers year in, year out. And that's just not going to be the nature of the questions you'll get at interview. So you want to find questions that would make you think, using the same A-level topics and concepts, but applying them in different ways and in new ways that you haven't done with A-level questions. For myself, that was, trying physics Olympiad questions like the BPHO, emphasis on the word trying. Don't think you need to do that and get every question right if you want to stand the shot at Cambridge. But yeah, so that kind of thing, physics Olympiad and just other, maybe more difficult questions you can find online that make you think about problems in different ways with the same physics and maths concepts, I think would be very useful practice for an interview.
Great.
Um,
Yes?
I think for me, following on from what Odu said, I think you have to kind of be comfortable with kind of not knowing answers and kind of finding questions that apply content which you might feel familiar with, but not necessarily feel familiar with that kind of applications and questions. So I think one of the websites that Richard mentioned, which was I Want to Study Engineering.org. So that was quite a useful website. And I'd say just kind of getting used to speaking kind of your thought process out loud, like Areeg was saying, is kind of another useful thing to keep in mind.
Great, thank you. Okay, so maybe we're nearing the end. I'll just read 2 more questions that are more admissions related. So do people that get an offer into Cambridge tend to do work experience, or is it not specifically required to do it? It's not a requirement. It's something that might help you in formulating your personal statement, but it's not a requirement for engineering. There are some subjects like medicine where work experiences are historically more important, although this year, because of the COVID-19 situation, it's been hard for many people to arrange work experiences. And will GCSE results have as much credibility as they usually do because of COVID-19? And does this mean, and if not, does this mean that A-level results have a greater credibility in terms of giving us an offer to study at Cambridge? So that's very difficult to answer. So for students who took their GCSEs this year, or who would have taken their GCSEs this year, are understandably very anxious about what will happen when they apply to university. And it's something that we are thinking about, but it's a bit too early to say exactly how the system will work. But it's important to remember that, you know, we always look at an application holistically. There are many ways of evaluating an application other than GCSEs. We've discussed the admissions assessment, but we also have your personal statement and your teacher's recommendations, and our interviews, which are, you know, how we do a big part of the cut during our admissions process. And so what happened this year should not make you anxious at this state, and it's something that I hope we can give a more specific answer to in the next 2 years. Okay, so I think that's all for the more admissions-based questions. And since it's already 6:30 and people need to go, I would suggest that we stop here, but I'd like to thank all of our panelists, so Dr. Roebuck for his wonderful presentation, our students, Areeg, Odu, and Ali, for providing all their, you know, firsthand knowledge from being students at Cambridge and having applied recently. And also very special thanks to Alexander Olive from Target Uxbridge for helping organize the event and for being here tonight. As Richard mentioned earlier, if you have any questions, do feel free to email the engineering admissions email or myself at Magdalene, and I'll be happy to help you with any specific problems related to your application. Okay, well, thank you very much and good night.